Hey guys, I'm the math professor, Kyle Martin. This is the channel where I do your math homework fast and accurately. All right, today we're talking all about compound inequalities. And we're going to tell you a few things in this video. First off, we're going to tell you the two types of compound inequalities. We're going to give you 3 examples. All right, and then we're going to solve graph and write the interval notation for each of those. And then one thing before I kind of move on here is please consider subscribing. Here's an inequality for you. There are greater than 98% of you that aren't subscribed. Okay, it takes a ton of effort for me to make these videos, guys. It takes one click of a button to subscribe. Please do it. It really helps, and I can keep making these videos for you. I know you use them, otherwise you wouldn't be here. Click that button. All right. Last thing, there's timestamps in the video player down below. All right, so you can scroll to whichever problem you need. Let's get into it. All right, guys, to start off here, we have our 2 types of compound inequalities, and they are these. They are and or. All right, and or compound inequalities. And compound inequalities, what this looks like is you're going to be working with 2 numbers here, 2 kind of critical points. It doesn't matter if it's an open or a closed dot, but what an and compound inequality does is it's shaded in between those. All right, it's shaded in between. It includes a kind of a range of values in between those 2 values. All right, an or compound inequality, again, if I had, let's say maybe in this one they're both open dots, what this would do is they would shade apart from each other. All right, they shade apart. So this one would be going to the left, this one would be going to the right. This is an and, this is an or compound inequality. All right, our first example is an or compound inequality. And the way you solve or compound inequalities is you solve these separate, these kind of 2 parts on either side of the word or. This first one, let's solve it really quick here. Let's see, I need to subtract 4 on both sides. This gives me 2x is greater than 6. Divide both sides by 2, and of course, x is greater than 3. All right, and then I have to do the other side. The other side here on this one, here's my x term, so I'm going to move the 1 over by adding it. This gives me 3x is less than negative 6, divide by 3. Divide by 3, and x is less than, remember our sign doesn't switch here because what we're dividing by is a positive, even though this is a negative. But negative 6 divided by 3 is a negative 2. Okay, so that's how we would solve those. It's x is greater than 3 or x is less than negative 2. And then the graph of this, we're going to graph these actually together on the same one. So here are 2 points. Instead of using 0 in the number that I've done in videos past, if you need those, here's a video of that. But if you look at these ones, here I can just put negative 2 to the left of 3, because that's how they're oriented on the number line. All right. In both cases, we're going to have open dots. And then since this is an or, I know I'm going to shade apart, but let's just double check. Is x greater than 3? Is that going this way? Yeah, of course it is. That's going to be like that. And x is less than negative 2. Is that going this way? Yes. Yes, it is. All right, so we have a solution. We graph this. And then the interval notation for these. This has 2 kind of snippets of our graph, of our shading. So we're going to need 2 parts of our interval notation, which means for this part, I'm going from negative infinity to negative 2. Both are going to have parentheses, and this one's going from 3 all the way to positive infinity. 3 to positive infinity. Okay, and then some teachers will have you put what's called the union symbol in between those, because you need both. You're going to union those together, and either part, if you have a number you're working with, that could be a solution if it falls within either of those 2 sets of the interval notation. All right, so since number 1 was an or compound inequality, you probably guessed that we're going to do an and compound inequality for number 2, and you were right, all right? But this one looks a little interesting because these are both going the same way. So let's see if this really is an and. If they both go the same way, is it possible that they can meet in the middle? Let's try it, all right? Here, this one, I need to, let's see, get my x term by itself, so I'm going to add 8 to the other side. And when I do that, I have negative 4x is less than or equal to 24. Oh, this is why, because here when I divide by a negative 4, my sign has to switch, okay? So instead of x being less than or equal to, it's actually x is greater than or equal to negative 6. All right, over here we're going to solve this one separately. Right, solve both those separately. And on this one, I'm trying to get my x term by itself, so I need to add 3 to both sides. And now I have 2x is less than 10. And then all I have to do on this one is divide by 2, and of course x is just less than 5. All right, so now those are pointed towards each other, which is good because this is going to be an and compound inequality. All right, so that's our solution, our graph of this. I'm going to have a negative 6 on this side, a positive 5 on this side. Let's see, the negative 6 is actually going to have a closed dot because it has an equal to with it. And the 5 is going to have an open dot. All right, so double check that these are actually going together. X is greater than -6, yes. Now I can't go the whole way because this stops. It's like another stipulation on my inequality, okay? So X is less than 5 has to go that way, and you're stuck in between because these two rules kind of tell you have to go in towards each other, which means you can't go past in this section, so you're stuck in the middle, right? Which means that there's only going to be one piece of the interval notation, so there's only one piece of the graph. And so this interval notation is going to go from -6 to 5, and at -6 is going to have a bracket, and at 5 is going to have parentheses, and it looks like this, our solution graph and our interval notation. All right, our last example, number 3, says -6 is less than or equal to 5x plus 4 is less than 29. What? This has two inequalities in the same one? Yeah, all right, it does. And whenever you see one like this, where there's two inequalities in the same kind of portion here, for this compound inequality, you're gonna think this is an and. Remember our ands and ors? This one's gonna be an and. So these are gonna be going together eventually. It is possible to write this so it can look like an or, but technically that's not mathematically right. So in your textbooks and things, when you see it written all together with two inequalities in the same part, you're thinking and. All right, let's try it. So this almost has like 3 sides to it, the left, the middle, and the right. So when I move my 4 over, I have to actually move it to all 3 parts, the middle, the left, and the right over here. Okay, so I was going to cancel my 4. -6 minus 4 is a -10. All I did is subtract there. It's not dividing or multiplying by a negative, so I can keep my signs the same. In the middle, now I only have 5x, and then over here is less than, well, 29 minus 4 is 25. All right, and this is going to turn out nice because when I divide by 5, everything is divisible by 5 on all 3 parts, left, middle, and right. And I would get a -2. Again, what I divided by was a positive, so my sign isn't going to dictate the change of this. It's going to stay less than or equal to x is less than, and over here is going to be a 5. Okay, so your answer to this actually looks like that. All right, and when you go to graph this though, this can be a little bit challenging. You almost want to think of it as 2 parts, so kind of break that apart now into those 2 like we had in numbers 1 and 2. Okay, what I mean by that is you can kind of, if I cover this part up, you can kind of see that we're going to have an x is less than 5, all right, for our second part with that 5. But then to work with this, well, remember how we were switching around in our other video? We'll link that here. If I want to write the x first and then my -2, you have to look at where it's pointing. Here it's pointing at the -2, so down here when I write it separately with the x first, I want to keep that pointed at the -2. All right, so now I kind of broke this box into these 2 ovals. And I am able to graph that, all right? In fact, if I do graph it, those 2 parts I'm working with are a -2 and a 5. At -2, we're gonna have a closed dot. And at 5, we'll have an open dot. And let's see, if x is greater than or equal to -2, that's shaded to the right. I'll stop there because I know I'm gonna have to come back with the 5. X is less than 5. Again, it's only going to have one kind of snippet of our interval notation from -2 to 5. Oops. From -2, there we go, to 5. -2 is going to get a bracket around it, and 5, since it's an open dot, is going to get a parenthesis. So let's see. We have kind of some different parts here. We have our solution up here in this rectangle, our graph, and then our interval notation of this compound inequality.